generation, and here we have the third generation. In the audience with us here, we have the fourth generation. The fifth generation is now running the store, someone has to do it. So we've been doing this for a while. I worked at the company for 6 years, and during my time there, I found a few problems that I would hope that we could solve. The first problem that we found is that there's no accurate way of predicting what our store sales are going to be. And this problem causes two other problems to happen. The first one being that we have stock imbalances because our production is too standard, so we're easily overstocking and understocking. And that also makes our workforce needs very unpredictable. In order to solve these problems, I brought a team together. I'm here with Millie and with Gonzalo. And together we're going to solve one main goal. And the main goal is to find a way to predict what our future sales are going to be. In order to reach this goal, we have a few hypotheses. The first one being the one that my grandfather already came up with. He used to hold a notebook where he would write down what the store sales were and what the weather was for that day. So his hypothesis is that there's a correlation between weather and store sales. The second hypothesis that we have is that there is seasonality, holidays, and specific weekdays play just a bigger role in store sales. And of course, we've got to have a hypothesis 0, which states that there's no correlation, but we hope to disprove that one. In order to prove or disprove these hypotheses, we have two main metrics. The first one being the total sales for the day, and the second one being the number of customers that we have. So, first going to take a look at the weather data. We're going to compare the daily sales and customers to all the weather features that we have found. The darker the color, the less correlation there is. They're all dark colors. So secondly, we found that there's no one-to-one correlation between the weather data and the store sales or the customers, but we hope through machine learning to find if there's maybe a 1-to-2 or a 1-to-3 correlation. So the first type of model that we're going to try to use is a linear regression. We have our doubts if this one is going to work because it's quite a simple model. It does run fast and it's easy to use, but it doesn't take into account things like seasonality, holidays, and special days. To measure the performance, we have two main metrics. The first one being the mean absolute error. We make a prediction and we have the actual value, and we're going to see what the difference is between the two of them. And then we also have the symmetric mean percent error, which is basically that value presented as a percentage. So as we thought, it didn't run very well. The red dots are all what the model tried to predict, and the blue dots are what the actual values are. The green line here indicates how far off it was. We're about, on average, 41% off, which isn't a very good number. But there is a better way to do this, and Gonzalo can tell us all about it.
So, as a result of our data exploration, we found that there is actually seasonality in our sales. We have seasonality both weekly and yearly. So in this graph, we can see the daily sales during the 2022, and with each line is representing one specific day of the week. So we can see that in Saturdays, we are selling much more than, for example, on Monday, that is our red line. Saturday is the blue line. And then we can also see that during the year, we have peaks on specific holidays, and then we have a clear valley here during the summer holidays because people will be on vacation. So we continue with our next step, which is the time series, which is a different approach with machine learning. And this one allows us to consider this seasonality, the holidays, and we can also include the weather. For the weather, we selected three main features. They are the average cloud cover, the percentage sun duration, and the max wind. So with this feature, we are trying to predict our two indicators, which are the daily sales and the number of customers. For measure the performance of our model, we will use the same metrics that for linear regression, so we are able to compare the results. So we tried with three different models. We started with K and N, with an error of 29%, which is lower than the 41% that we had in linear regression, but it's still high. So then we went with Prophet by Facebook with an error of 9%. And finally, we get to Grey Kite with an error of 6.86. So we decided to advance with Grey Kite, of course. And then this 6.86 that we mentioned is for the base model. And then we try the different variables that we mentioned before. These are the weather, including holidays, and including both holiday and weather. So this is the error. So of course, the less the error it is, the better the model. So we decided that we can see that our best model is including both holidays and weather. This is for daily sales. We also tested our second indicator, that is the number of customers. So here we can see again that our lower error is when we include both holidays and weather, even though each one of them separately are not getting our base model any better, but when we combine them together, we have the best model. So this is the result of the model for our both indicators. So this is the days that we are training our model, and we are comparing the predictions versus the actual values. Here we have with a blue line the predictions, with a red line the actual values, and then we also have an upper bound and a lower bound, and we can expect that 95% of the cases the actual values will be between these two bounds. So we will zoom in so you can see a little bit better. Here this is 1 week. This is the last data that we have. So we are training and testing in the last week our model. Here we have both the actual value, the predicted value, and then we are actually predicting our next week. So we will only have the forecast and both upper and lower bound. And then the final user will see the result in a dashboard that we are having in Streamlit, and Brandon will explain.
So what we see in the dashboard here, once we turn dark mode again, because it looks way nicer. We have the sales and the customers lined up with our predictions per week. Underneath it, we have the delta difference between what we predict and what last week's sales were. So we see that on Tuesday we expect the store sales to go down, because for that day we're expecting bad weather. And then we see towards the weekend that the store sales are going up, because we have a lot better weather during the weekend. So according to those values, we can make a few recommendations. The main recommendation is that we raise production and sales staff for the weekend to because it's going to be a lot busier the weekend. We can lower the sales staff for Tuesday, because we expect it to be a bit quieter on Tuesday. Then maybe we can use the sales staff in production on Tuesday to better prepare ourselves for the weekend. So in conclusion, we were finally able to test my grandfather's hypothesis correct. It only took us 50 years and 2 generations. To reiterate, that main hypothesis was that there's a correlation between weather and store sales. Our second hypothesis was that there's a seasonality, holidays, and specific weekdays. We've proven that that plays an impact as well. So we can gladly disregard our hypothesis 0, and most importantly, we have actually a working model that we can use to predict what our future sales are going to be. So, thank you all for your time and enjoy the rest of the